Hello students, welcome to my study channel. Today we will study about rational numbers. Let us start. You see, already we have known about the natural numbers, whole numbers, integers. We have also known the fractions, the fractional numbers. Today we will study about rational numbers. What are rational numbers? You see, the numbers are formed P upon Q. You may call it P divided by Q or P upon Q is a rational number where P and Q are integers, okay, and Q is not equal to 0. Mark it. Suppose we will take two integers. Suppose P is equal to 2, Q is equal to 3. So 2 upon 3. It is a rational number. You see, here Q is equal to 3, 3 is not equal to 0. So 2 upon 3 is a rational number. Suppose I will take P is equal to, suppose minus 3. Suppose. Is it a rational number? Yes, it is a rational number. Minus 3 upon 5, because minus 3 is an integer, 5 is an integer, and 5 is not equal to 0. If I write like this, suppose minus 3 upon minus 6, it is a rational number. Because you see, minus 3 is an integer, minus 6 is an integer, and minus 6 is not equal to 0. So, P upon Q, where P and Q are integers and Q is not equal to 0, they are called rational numbers. But can you tell me, already you have studied about fraction. 2 upon 3, you can call it a fraction. Can you tell minus 2 upon 3 is a fraction? No. So, for a number to be fraction, you see, both the numerator and the denominator should be a whole number. But Q will not be equal to 0 because we have 0 in the whole number. In case of rational numbers, we are taking P and Q as integers and denominator is not equal to 0. In case of fraction, suppose I am writing P upon Q is a fraction where P and Q are whole numbers. They are not integers. And Q is not equal to 0. The denominator cannot be 0. 0 can be divided, 0 can be quotient, but 0 cannot be the divisor. We cannot divide a number by 0. So 0 cannot be a divisor. So we write like this. So you see the difference. It is seeming like a fraction, but it is not a fraction. Why? The numerator and denominator, they should be whole numbers and denominator should not be equal to 0. But you see minus 3, that is not a whole number. 5 is a whole number, but minus 3 is not a whole number. Both numerator and denominator, in the case of fraction, they should be whole numbers and the denominator should not be equal to 0. For which I have written the Q is not equal to 0. So this is the basic difference we will follow between a rational number and a fraction. So let us move next. I erase it and you Just mark the difference. You see, every natural number, whole number, integer, fraction, is a rational number. Each natural number, every natural number or every whole number or every integer or every fraction is a rational number. Because you see natural numbers, you know it. These are the counting numbers. We count for different objects. So these are the counting numbers. These numbers help us in counting. And when we start counting from 1. And whole numbers, you see 0 is included along with the natural numbers. Then come to integers. You know, already I have discussed in the previous video how it is helpful to denote the ideas that are opposite in the direction of sense. And fraction, already you know. So each natural number, each whole number, each integer and each fraction is a rational number. You see, suppose 0. We can express it as a rational number. How? We may write 0 is equal to 0 divided by 1, 0 upon 1. You see, 0 is an integer, 1 is also an integer, and 1 is not equal to 0. So, we can express 0 as a rational number. Suppose minus 2. It is an integer, that is equal to minus 2 upon 1. So we can express this integer as a rational number. And fraction, you can easily do it. You take any two whole numbers except the denominator that should not be equal to 0. Suppose 2 upon 3. These are whole numbers and 3 is not equal to 0. This is a fraction. And this is a proper fraction, you know. In the lower standards, already you have known in the previous classes, already you have learned. And you see, 2 is a whole number, 3 is a whole number, and 3 is not equal to 0. So 2 upon 3 is a fractional number, or it is a fraction. So, and you know, the proper fraction is always, its value is less than 1, and the improper fraction, that is greater than 1, you know it, correct? How we convert the improper fraction into the mixed numeral or the mixed fraction? We find there one whole number and one proper fraction. Just we convert the improper fraction into the mixed fraction or mixed number, and from mixed numeral we bring back to the improper fraction. Already you know it. I don't want to waste your time. So be fundamentally clear. These are most important points. Just I am discussing with you. Whenever if you find any doubt, then you comment. I will try to give you the best. So let us move to types of rational numbers. It is better kinds of rational numbers. Kinds of rational numbers. You see, positive rational number, positive rational numbers. And the other one is negative rational numbers. You see in the positive rational numbers, you see we are having a numerator and denominator in each rational number. So in a rational number, there is a numerator, there is a denominator. Either both numerator or both denominator should be of same sign. You see 2 upon 3 or minus 2 upon minus 3. So both the numerator and denominator are either both positive or both negative. Then they will be called the positive rational numbers. You see, in the case of minus 2 upon minus 3, suppose minus 2 upon minus 3, that is equal to, you multiply minus 2 upon minus 3, this is the part, you multiply both the numerator and the denominator by minus 1. So you see, I multiplied minus 1 to the numerator and also to the denominator. That means I have multiplied nothing, because minus 1 upon minus 1, that is 1. But you see the result, minus into minus, that is plus, so 2 into 1, that is 2 upon 3. So you tell me, it is a positive rational number or not? What you feel? That both should be positive, both the numerator and denominator should be positive. So minus 2 upon minus 3, that is also a positive rational number. So how will you know which are the positive rational numbers? Now you will see whether both of them, both the numerator and denominator, either they are positive or both of them are negative. Then those rational numbers will be called positive rational numbers. Okay? Just erase it. Then come to negative rational numbers. Suppose minus 2 upon 5 or 2 upon minus 7. And you see, the numerator and the denominator are such that when one is negative, the other one is positive. When the numerator is negative, the denominator is positive. When the numerator is positive, then the denominator is negative. In these cases, the rational numbers are called negative rational numbers. When the numerator is positive, when the numerator is with positive sign, then the denominator is with the negative sign. When the numerator is with negative sign, the denominator is with positive sign. In these cases, these rational numbers are called negative rational numbers. So be fundamentally clear. Don't be so fast. You are in the learning stage. Just you mark what is happening and you follow step by step. We will be going on solving. So these are the kinds of rational numbers. Let us move to properties of rational numbers. So properties of rational numbers. Now we will not go into the closure property, associative property, distributive property, no, commutative property, no, we will not go to that now through different operations. Just to mark properties of rational number. Suppose P upon Q. You see, P upon Q is a rational number, and you multiply both the numerator and the denominator by a non-zero integer. Let M be a non-zero integer. That means you cannot take 0. That may be a positive integer, that may be a negative integer, but that should not be equal to 0. You cannot take 0. So m should be the non-zero integer. So let us multiply the m both by the numerator and the denominator. So I can write like this. And the value will be same. So why here it is non-zero integer? Because if I take 0, then I will have to multiply q by 0. So q into 0, the denominator will be 0. So denominator cannot be 0. And 0 cannot be the divisor. So here the point is mentioned, it should be non-zero integer. Okay? Suppose 1 upon 2. I am taking m is 3 here. I may write 1 into 3 divided by 2 into 3. That is equal to 3 upon 6. Value is same. But both the numerator and the denominator, that should be multiplied, they should be multiplied by a non-zero integer. Clear? Come to next. Like this, suppose p upon q is a rational number, and I will have to divide by a common divisor. Let it be m. Here m be the common divisor. So that is equal to, if you extend the bar, this is p at q, p upon q. So this value will be equal to this. So we divided both p and q by a common divisor. Here you cannot take it as 0. The properties of rational numbers under addition, subtraction, multiplication and division. Next, finding some rational numbers between two given rational numbers. Third, comparison of rational numbers. So you see, we will discuss today on properties of rational numbers under 4 basic operations: addition, subtraction, multiplication and division. Next, we will have to find some rational numbers between two given rational numbers. We will have been given two rational numbers, and we will find some, whether 3, 5, any number. We will find between two given rational numbers. Then third, comparison of rational numbers. We will compare between, suppose between two rational numbers, which one is greater than other. So we will discuss about that. So before going to that, we will discuss now the properties of rational numbers under different basic operations. So before going to rational numbers, let us recall the whole numbers. What we have known through these operations. What are their properties? Just remember, all the whole numbers show closure property commutativity, that is commutative property, and associativity, that means associative property under two basic operations, under addition and multiplication. Just I want to take a brief discussion. You see, all is important. Why? You see all the whole numbers. So closure property, commutativity or commutative property, and associative property under addition and multiplication. Why not? Under these two operations, subtraction and division. So you see, suppose you take any two whole numbers. Suppose we will take 3 and 2. These are two whole numbers. You see, if you add them, 3 plus 2 is equal to 5. So the sum of two whole numbers is a whole number. You see. So they show closure property under addition. Then come to subtraction. Okay. 3 minus 2, that is 1. It's okay. 1 is a whole number. But if I write 2 minus 3, that is equal to 2 plus of minus 3. But I cannot use like this because in the whole number there is no negative whole number. These are not included in the negative signs. These are not included in the whole numbers. So we cannot write like this. So we cannot use this. Then come to multiplication. You know 3 multiplied by 2 or 3 into 2 is equal to 6. Or 2 into 3 is equal to 6. In any order you multiply, the product remains same. Then come to division. Suppose 3 divided by 2, that is 3 upon 2. It is not a whole number. If I take 6 and 2, these are for example of two whole numbers. 6 divided by 2, that is equal to 3. But if I write 2 divided by 6, that is 1 by 3. It is not possible. But if I take 2 and 0, I cannot write like this 2 divided by 0. I cannot write like this. 0 cannot be the division. So, all the whole numbers, so closure property only under addition and multiplication. Like this, we can also prove the commutativity property, associativity property under addition and multiplication. I erase it. Then come to commutativity or commutative property. You know commutative property, that is also called order property. If you change the order of the numbers, okay, then in case of addition and multiplication, that means the sum and the product remain unchanged. How you see? Suppose for addition you will see 3 plus 2 is equal to 5. If I change the order, if I bring 2 to the first position, then next I bring the 3. You see, in both cases it is also 5, it is also 5. There is no change. So, when I change the order of the numbers, I use the basic operation addition. I will now use the basic operation subtraction. 3 minus 2. 3 minus 2, that is 1. But if I write 2 minus 3, that is 2 plus of Minus 3, I cannot use this negative numbers in case of whole numbers. Then you come to multiplication. 3 multiplied by 2. Again you see 2 multiplied by 3. In both the cases, you see the product remains unchanged. Then come to division. Suppose I will take 6 and 2. 6 divided by 2. Yes, it is 3. But 2 divided by 6, it is 1 by 3. So I cannot write 6 divided by 2 is not equal to 2 divided by 6. This doesn't hold good. So all the whole numbers show commutativity under addition and multiplication. Not here in the case of subtraction and in the case of division. So then we will come to associativity. You see, I will take 3 whole numbers. Suppose 1, 2 and 4. So now you see 1 plus 2 plus 4. So I have to prove the associativity or associative property. So I will now use the basic operation. I will take the basic operation addition here. So here is the addition signs. You make first one group, you create one group. That is equal to, you see, 3 plus 4 is equal to 7. So I change the grouping of numbers. Then I will add it. 1 plus, then we will have to do the bracket work. 2 plus 4, that is equal to 6. That is equal to 7. And if you write like this, that is also 7. So all the whole numbers show associativity property under addition.